What I failed to do in that last video is explain what happens at x equals 0. X equals 0, so y equals 1 over 0. Yeah? Well, if you set x equal to 0, this is what you're trying to demand, that this exists. So let's have a quick look at this again. There's the thing, and this comes up here and goes closer and closer and closer and closer and closer. And each time we half x, we double, that doubles the value of y. And you could carry on doing that over and over and over again. With x, as x gets smaller and smaller and smaller, y gets bigger and bigger and bigger. So if we chose an x very, very close to 0, y would have a value very, very close to infinity. But no matter how close that is, how close x is to 0 and y is to infinity, we can always find a value of x where there's an even bigger value of y. So we can approach x equals 0 closer and closer and closer. What we say is that as x goes to 0, y equals 1 over x goes to infinity. Goes to infinity, not is equal to infinity, because infinity is not a number. It's not a definite number. Well, even if it was a number, it wouldn't be a definite number. But it's not even a number. It's not in the system of numbers. So we use this kind of. We can say these for definite. We can't say this for definite. This is the point is that because infinity is not a definite number, 1 over 0 is not definite. It's not usable. Interesting though.